Hi, my name is Edward Jin, and this is Lab 1 Charge Tapes for Physics 2212. In this lab, we focus on understanding electrostatic interactions through hands on experiments and computational modeling. This experiment had three main objectives, which were to observe how two pieces of Scotch tape interact when they are electrically charged, use GlowScript, a computational model, to simulate those interactions, and then estimate the amount of charge on each tape and calculate the corresponding number of electrons that were either gained or lost. I have attached some of the findings below that we will get into a little bit more later. We began by preparing two pieces of tape and charging them. We noticed that the tapes repelled each other, which indicated that they both had the same type of charge. In this case, it was positive. From there, we collected data including the mass, length, width of the tape, and we also measured the distance between the two repelling tapes. This came out to be approximately 2.5 centimeters or 0.025 meters. Here we also have the number of atoms in the atom area, and we will be using that as well later. So to find the charge on one tape, we applied Newton's second law and set the electric force equal to the gravitational force acting on the tape. Using this relationship, we were able to solve for Q, the amount of charge. This result was a charge of roughly 1.267 times 10 to the negative 8, which I showed earlier in coulombs. And from that, we calculated the number of missing electrons to be about 7.6 times 10 to the 10, showing a deficiency of electrons on the tape. So here in our first simulation, we treated each tape as a point charge. This model allowed us to check if our calculated charge value was consistent with the physical separation between the tapes. And so we wrote a function in GlowScript to calculate the electric force using the distance between the tapes and confirmed our earlier estimate of 1.267 times 10 to the negative 8 coulombs, as the math ended up working out. Next, we moved to a more detailed model. Instead of a charge point, we simulated the tapes as lines of charge. This gave us a more realistic representation of how the charge is distributed along the length of the tape. Using this model, we divided the tape into segments, each representing a point charge, and calculated the total electric force acting on the top tape due to all these segments of the bottom tape. The total electric force from this model was approximately 1.82 times 10 to the negative 3 newtons, which matched the gravitational force, which again confirmed that the tapes were remaining in equilibrium. And here we also show that the magnitude of the charge on one piece of tape, where each tape is a line of charges, is approximately 2.42 times 10 to the negative 8 coulombs, which is different than the point charge model that we had earlier. And here I have the values of the magnitude of gravitational force and electric force, and they're pretty consistent and equal. And again, there's the measured electric charge. So some assumptions, approximations, and idealizations that were made. We included the assumption that air resistance and friction are negligible, which is not necessarily going to be true all the time in a real world situation. We also assumed that each piece of tape had roughly the same amount of charge, uh, evenly distributed, which also may not be true in most cases as well. Some of those errors that may appear would be unequal distribution of the charges on the tape, like I mentioned earlier, loss of charges due to environment or handling in general, and then external forces like friction that were not included in our model because we assumed that they were negligible. We also considered some theoretical what if questions. For example, what if the protons and electrons switched roles? In that case, we still observe the same behavior, just attributed to the proton loss instead of the electron deficiency. The physics would remain unchanged because the direction of forces depends only on relative charges and not their labels. Uh, and then for the y, we also compared our point charge and line charge models, and both are useful, but the line charge model may be a little bit more accurate, as in this context, it reflects how the charge is actually along the tape, allowing a more precise calculation.